This type of questions we usually have, right? And sometimes we'll be able to answer those questions, but most of the times we are in lack of giving a proper answer for those type of questions, right? Okay. So hope this lecture would be a brief introduction about the mathematical models, and then how it is applied into day-to-day life. And before I enter to my lecture, let me tell about a few things about myself. I'm really happy and proud to say that I'm an alumni of PSG CAS. I did my MPhil in 2002 under the guidance of Dr. D. Gunasegaran sir. Full-time, I was the full-time MPhil scholar in 2002, and Professor Gunasegaran sir had given me an opportunity, because those days lack of professors were supervising scholars, but most of the students were liking to join MPhil. So in that period, I had a chance to meet Dr. Gunasegaran sir in front of one of my professors, and I requested him, and he immediately accepted to take me as a student. And that was a turning point in my career, and I started my research study in PSG CAS. I still remember the library of PSG CAS and the department and the supporting faculty members and students. We learned many things from there. I'm really happy to meet you, all the youngsters and students who are now the students of PSG CAS. I hope that you are all enjoying the environment of PSG CAS, and you are making use of all the faculty members of PSG CAS in improving your knowledge. And as a part of your this like arranging guest lecturers, definitely students will be interested to learn something from outside faculty members, because of new face, and because of the topic which are not covered in our regular syllabus. Am I right? So hopefully you will be liking this lecture for another 1 hour. Within the sharply within 1 hour, I will wind up my talk, and feel free to ask anything in chat box during my lecture. You can interact with me, and I want your interaction. Fine. Mathematical models plays a very important role in our day-to-day life, right? But knowingly or unknowingly, we are applying them, we are using the models, but without our knowledge, we apply and we find a solution for our real-time problem. So one part of my lecture is to introduce what is the model and what is mathematical model. Model is a very general term, and how our mathematical models is differ from the general term model. And then the second part of my lecture is on a particular type of model which is widely used in the science and engineering field, called graph, which is a fantastic model which can be easily applied everywhere. And how this particular model is going to apply in our day-to-day life, and especially in particularly in social networking. And we know many people are a part of the entire system, but they don't know how the mathematical models are helpful for the entire system. Belonging to that particular system themselves, they used to ask what is the use of mathematics. right? So as a mathematics students, we should know that how our mathematical models are beautifully applied in our day-to-day life, especially in social networking and to all other science and engineering fields, right? Particularly, I'm going to consider the social networking ideas, and I'm going to explain how the mathematical model social network. Fine. So let me share my PPT. Can you see my screen?
Yes, sir.
Okay. Mathematical models in real-time applications. It is actually a very elaborate topic. We cannot take all the models and in all real-time applications and all, because modeling means everywhere, whatever the thing which we are doing in our mathematics note are models only, and real-time applications are there for every application, for every models. I'm not going to touch everything, but the overall the content that as I explained earlier. First, what is model? Then, what is the mathematical model, and where we applied in the day-to-day life, and more particularly, a model graph, how it is applied in the social networking and in other fields also. Right. So, we know what is a model. A model is a very general term. A model is something, is a structure which we use for understanding about the actual, the original one. We cannot construct the original one to analyze and to understand the problems of the entire situation. So we used to take any model itself and we would go for the original one. So that is the purpose of model, and here you can see the entire plan of an apartment is giving us a model, and we find out if there is any problem, and that problem, once if you identify from the models, that can be rectified in the original one, right? You can see here a city model, and which has given an excellent way of finding the routes between the places, and finding the distance between the places, and everything can be understand from the model, and that is used for the original one. So the model is nothing but is a brief description of original items. A car, before designing a car, a model is going to be constructed, and finding out the pros and cons of the models, rectify them by studying the model itself and implementing it in the original one. Right, okay. Now, let me come to a mathematical model. Okay, fine. So we know what is model. Now you would have seen these type of problems, puzzles in social network pages everywhere, and most of the times when we look into this, we used to pass to the next one without seeing this, because of having a confused mind to find out the solutions for this and that, right? Those who don't know anything about mathematics, they also can solve this type of questions. They can solve by trial and error without applying any mathematical ideas, right? So by looking into that first row, an apple plus an apple plus an apple, which gives 30, then what may be the cost of an apple? Anyone can answer very quickly. Anyone can answer what is the answer for this one, right? Okay, fine, very good. Some of them are giving answer because as we are mathematics students, we are really curious about the puzzles, and we started to answer for them. Very good, nice. Now, what is my aim to show this particular picture is, as a mathematics students, we should know how to use our model, mathematical model ideas for this such type of questions. Of course, only mathematics students can do, not others. And mathematics students, mathematicians can easily identify the answer uniquely, right? And we can give the reason for the answer, and suppose if the solving is not possible, that can also be given with a reasoning. That is the use of mathematical models in solving that type of questions, right? So as a mathematician, so what we have in our mind immediately on seeing the first row of this particular thing, we immediately have an equation in our mind. Of course, it is 3a equal to 30. Am I right or not? 3a equal to 30, right? So what you are using? You are using an equation equal to, and left side an operation multiplication with the constant 3 and variable a, and you are giving an equation for 3a is equal to 30. Once if you change that particular situations into a mathematical model, we can solve that. So what you have now is 3a equal to 30. That is what a model. That is what a mathematical model. Any model which is used, which is written in terms of mathematical operations and variables and constants and other tools, mathematical tools, that is mathematical model. Right? Okay. So having that in the mind, when we go to the second equation, we used to count how many number of bananas, and we used to find how many number of apple. So there are 4 plus 4, 8 bananas and 1 apple. So a plus 8, b is equal to 18. That is another mathematical model. Okay. So we go for the third one. All right. Okay. 4 minus 2, c equal to 2. C means number of coconut. Right. Sushmita, you are right. Let me come to the point. Fine. This is the way of writing the mathematical equations when 3a equal to 80, 30, a plus 8b equal to 18, 4b minus 2c equal to 2. So our question is now is in terms of a mathematical model, not in terms of the original situation. It is in terms of whatever questions and picture, we give it in the form of mathematical language. That is called the mathematical model, right? Okay. So on seeing this one, c plus a plus 3b equal to what, we have several questions in our mind. Okay, we need 3 variables, a, b, and c, right? Now all our algebraic ideas are coming into our mind. Only mathematicians can think in that way. What others can do, they can calculate by substituting second equation, and by trial and error they may calculate the banana cost, apple cost, and coconut cost. But we have a lot of methodologies that can be studied in algebra, and here algebra, and if it is a differential equation, you may have lot of methods and ideas in differential equations and so on, right? So what we have in our idea, as we have 3 variables, we need 3 equations. Are they do we have 3 equations? We have to count it. Yes, we have 3 equations. 3a equal to 30, a plus 8b equal to 18, 4b minus s. Okay. Oh, fine. So 3 equations means it gives, it will certainly gives a unique solution for a, b, and c. Suppose if there are only 2 equations, we can say that a unique solution is not at all possible, right? So there may be many number of solutions, and that can also be found using the graphical techniques and all. Whereas the other people can give only one solution, and they may give only this is the solution. But only we can give multiple solutions by using graphical ideas also. So this is what the beauty of the mathematics, right? Okay. So we solve this and we substitute in C, A, B, C are calculated, and putting them it gives 14, right? Okay, so what is the way of finding the solution? Just by calculating them using the algebraic structure, but we give a different solution and different ideas, different techniques of algebra for solving this particular problem. That is what the beauty of mathematicians, right? So completely a model has the flow chart. If there is a problem situation, that has to be formulated as a problem. So we need to convert that into a problem, that is changed into the formulation, and we analyze the problem. Suppose in some cases, if you want to convert that into the graphic data, that has to be used. Otherwise, you can obtain the mathematical model directly, find the solution, and interpret that particular data with a problem situation. So this is for the flowchart of the model. We know this very clearly how this beautifully applied in the problem situation, and we interpret the solution of the problems to the problem situation, right? Okay, let me give another example of a same algebraic structure. You have 100 rupees in your hand and your class strength is 26. Okay, you want to buy some pen and pencil, and you know the cost of pen and pencil 5 and 2 rupees, and you want to purchase 26 items in total to supply to all the students to write something in application form or something. They want a pen and pencil, they want to be distributed, right? Okay, fine. So you have 100 rupees, you want to use that entire 100 rupees for purchasing the total number of 26 items, right? So having this in the mind, if you go for a shop and if you give this problem to the shopkeepers, they used to take some number of pencil, like 10 pen they may take, and they can calculate 50 rupees. For the remaining 50 rupees, if they take the pencil, it will be 25. 25 plus 10 will be 35, and they will adjust the number of pen and pencil and other things. But in your mind, you can simply convert this into the mathematical model. Am I right or not, students? Can you give me a simple structure for this particular situation in chat box? Chat box? The question is, you want to buy 26 items. 26
Okay.
items.
ஒரு 5 மணிக்கு நான் வீட்டுக்கு வந்துடலான்னு பிளான் பண்ணிருக்கேன்.
Some pencil and to be used, right? Can you give this entire situation as a mathematical model? It is possible. It is possible by how? Just by taking an unknown terms, number of pencil, of course. Nandita has given an excellent answer. 5x plus 2y equal to 100, right? So having the variable x and y in her mind, yes, of course. And another equation also, Devadashini has given x plus y is equal to 26. Excellent. So this two condition is enough. These two conditions are enough because we need only two variable values, x and y. We have two equations, we can solve them. So we don't want to go for any other equations. And we are able to give an unique answer. Yes, we are able to give unique answer within a short span of time. Am I right or not? So just by taking this x plus y equal to 26, y is equal to 26 minus x. Take that 26 minus x in 5x plus 2y is equal to y, and you can get y over there, and you can simply substitute and find out the answer 16 and 10, right? And moreover, here this number of pen is more than the number of pencil because we need to use the entire amount. So we used, yes, the answer is right. 16 and 10 answers are right. So what we got answer, are we doing in trial and error? No. So this is the beauty of mathematical model, right? So how beautifully it is applied in the situation and we get the answer. And to the next point, the same thing. If it is in the form of inequality, Okay, of course, x plus y is equal to 26. The same x plus y, if the condition, if I add another condition that x plus y greater than or equal to 26, even if you purchase more than the number of students, it may be useful. Then if I given a condition like that, it will become an inequality. So once if an equation is converted to the inequality, we can use our graphical method of operation research to find the solutions. And there you can have many solutions sometimes, and the feasible region. From the feasible region you can find out the optimum solution. So everything are mathematical models. We have lot of things in our hand to apply everywhere, to apply every situations, to give the solution for the unknown people, right? So there should be a connection between mathematicians and non-mathematicians. There should be there is a bridge that has to be filled only by us, because we know the solution method and we know the tools and we know how to find a solution. But those people have lot of problems in their hand. They don't know how to formulate it. So once if you look into the problem, as a mathematics students, we should know how to formulate it. So that formulation is the bridge. Okay, so they have a problem in one hand, and you know the methodologies in your hand, and once the problem situation is converted into a mathematical model, you can solve them. That can be interrupted with the solution of the problem, real-time problem, right? Okay, so having this in our mind, day to day, we use many lot methods. Differential equation is a mathematical model. Integral equation is a mathematical model. Why we use differential equation? Rate of change. Whenever change comes, we need to study about how far the changes occurs. So that measurement is taken as the rate of change, right? So once if the rate of change is there, one variable in terms of other variable should be defined. So one variable in terms of other variable variation has to be calculated in terms of differential coefficients. Once an equation is formed in using differential coefficient, that becomes a differential equation is a model, is an again another mathematical model, and we know the methodologies to solve them, and we can give solution for them, right? So this way we have lot of models, and all the things that we are studying in mathematics are the ideas that we are using for solving the problems are actually the mathematical models. Fine. So we have to be proud to have those tools in our hand, and we have to use them, and others from non-mathematician can utilize them just by filling the bridge, right? Okay, fine. So that's why I told the formulation of the problem is very important. Once if you look into the problem, you should know how to formulate it. So day to day the models changes, model changes. We are not enough. It is not possible to have only a fixed number of models for our day to day life problem, right? So the model has to be changed, and the methodology of that particular model has to be used and has to develop. That particular methodology has to, that is what research, right? Okay, so on those days they have told on two equations with the two variables will give a unique solution, right? So that is the fundamental theorem of algebra. Okay, so that is what a basic concept of algebra, and that was the research one time. Once upon a time, that was the research. But now, the day to day, the new models are arising, and methodologies are developing by many researchers. Okay, fine. So let me go to in the next slides a beautiful model which is called the graph, which was actually invented in 17th century, and hope really you will be enjoying what is that particular type of model. If you have studied already graph theory, you would have known about this particular model. Yes, the Königsberg city in Prussia. Okay, so the city has this particular structure. A river passes through that particular city, and it divides, this river totally divides the entire city into four regions. Okay, four regions, and those land areas are connected in terms of seven bridges. In the earlier 17th century, Euler found a model for this particular city. The reason why they found the model for this particular city is there was a question that it is you have to start from one particular land area and passes through go and has to go through all the bridges exactly once and return back to the origin, the starting position, return back to your home. If you start from A, you have to go through all the bridges exactly once and you have to return back to A. That was a problem arises between the people of that particular city, and that that is not possible. That problem cannot be solved by trial and error. We cannot go every time to check whether it is possible or not. So there arise a model, and Euler found a model having points for each and every land areas, and the connections, I mean the bridges are taken as the lines between the points. So that particular thing, those days, he doesn't know it is going to be a very good mathematical model for almost all science and engineering field. But we know nowadays it is applied everywhere. Okay, and seeing this particular model, he gave the solution for this problem, that it is not possible because it is having odd vertices, odd degree vertices. You can see the vertex C has a odd degree. Because of odd degree, it is not possible. The reason is whenever you enter into one particular vertex, you have to come back from that. So entering one vertex, entering the vertex with one edge, coming out from the vertex with another edge. So it counts two. It counts two edges, right? So whenever you enter, you have to come out. So the degree should be in multiple of 2 only. It means the degree should be even number. If there is a single vertex with the odd degree, it never be possible, right? So later on, the graph become the graph having even degree vertices was called Euler graph, and we know the applications of this one in almost all areas. Okay, so what I want to say is this is the origin of the mathematical model graph. Okay, so in the later part of 17th century, this particular graph structure has not applied everywhere, but slowly the researchers found that it is a very beautiful model, and this research was going on. And in 18th and 19th century, and plenty number of not many number of papers and research articles came out of this graph theory, and we know now how it is applied to the present situations, right? Okay, so now what is a graphical model? Graph is a mathematical model. It can be used whenever the connections occur between the defined nodes. Between the defined nodes. Whenever two connections occurs between the nodes, we can apply the graph. So we could see the connections everywhere around us, everywhere, right? You are going inside a home and you are looking into the electrical network of the home. You can see many junction boxes are there in the hall, bedrooms, right? And the connections between them as the cables, right? So that connections occurs between the boxes. It means it can be modeled in terms of a graph, right? A network. You are going for a computer lab. You can see many computers are connected in terms of cables. That can be easily modeled in terms of graph, taking each and every computer as a point and the connections between the vertices as the edges, right? So graph can be easily applied, and once if you apply the graph mathematical model to the situation, you can solve many problems of that particular thing using the parameters of graph, right? So one side the research is going on for for finding the solutions for different type of structures and different type of problems are solved. In the other side, a lot of problems arises in the network and in other areas where nodes and connections occurs that can be easily modeled by graph. So these results and ideas can be applied to this particular situations to give the solution for. See the beauty, how beautifully it is applied. Okay, fine. So here you can see many type of networks of computer network that can be easily applied in terms of graph. Let me give some more real-time example for converting that into graphical items, graph terms. Structure of molecules in chemistry. In chemistry, we know the molecules are the bonds between the atoms. Atoms are connected in terms of bonds, maybe single bond or double bond. So that particular connections is represented as a molecule that can be easily modeled in terms of graph because of connections which occurs between the vertices. Circuit diagrams in physics. Of course, the components of a diagrams circuit can be taken as the vertices and the connections between them may be taken as the edges. Genetic structures in biology, chip designs in electronics, block designs in civil engineering, road maps, railway network, etc. Everywhere you can see genetic interaction network, transportation network. Of course, all the places are taken as the vertices and the routes between the places are taken as the edges, right? You can find out many solutions, shortest path problem and connectivity problems, colorings, matching, everything can be applied for this type of networks. So whatever the tools which we want from graph terms can be applied to everywhere. Ecological networks. The networks has some vertices which are the species of the nature and they are actually interconnected. They are actually, all the species are interconnected. So if we want to study about the ecological systems by the environmental activists, they can make use of this graphical structures and they can find out the solutions of the ecological system using graph theoretical term. Let me come to present situation of a social network. All right. Okay. So my remaining part of my lecture is on this particular topic of a social network. How this graph is applied in social networking and how we use the different parameters of graph in social network and how it is going to use in the future and what are all the problems that we are facing and what are all the research is going on in these things we are going to discuss. Suppose if time permits, we can go out of the social network also to any other field of any chemistry or any other field to apply this particular graph terms, right? Okay, fine. But we are somewhat interested in the social network graph. A graph means I have told already, it has two main components. The components are points and edges. Okay, fine. So whenever the connections occurs between the points, we use the graph term for modeling it. Okay. So think about your social network. Think about a social network. You have an account in Facebook. Facebook is a social network. Okay. So if you have an account in Facebook, are you alone? Are you alone in the network? If you are alone in the network, there is no use of a social network, right? So you should be connected with the people, right? So once if you are connected with the people, you become a node and the connection between the people become the edges. Here you can see some of the accounts, persons who are interconnected. Can you say how many number of points or vertices can be used for model this particular social network? You can see a diagram in the picture. How many points can be used? You can give your answer in chat box. Yes, very good. Very good, Melida. 8 points we are using for representing this particular structure into a graph. Fine, okay. Can you count the number of edges? Can you count? The answer is very simple. We can count, right? We can count and we can write the answer. But is it possible to count the edges in a very huge graph? I have taken a very simple example with the 8 for just for understanding. But think about your original graphical structure. Think about your original graphical structure. It has crore and crore accounts in Facebook or any other social network sites, right? So each and every one is a vertices. Okay. Okay. So if you take a huge graph, we need to study about many things from the graph. Nowadays, social network plays a very important role in decision making, right? Decision making by the people. The people who have a mindset, one type of mindset can easily be changed. That is because using the ideology of this social networking. Okay, fine. Now let me come to our mathematical part. You just imagine there are 12 people in the social network. As I told, people are represented as nodes, right? People are represented as nodes, so there are 12 nodes. The nodes, namely, okay, fine. What about the relationship? The relationship is maybe any type of relationship. It may be acquaintanceship, friendship, co-authorship, or anything. Acquaintanceship means just knowing person, not as a good friend, but knowing person. That is what acquaintanceship. And he may be a knowing, a well-known person, friendship, or any type of relationship, right? Okay. So people are represented by nodes, and their relationship are marked in terms of edges. Am I right? Okay. Once if you convert this in this form, it is what it is that graph, right? This is what a graph. Okay, fine. So this graphical structure, what is the use of this particular graphical structure? What are all the things that you can infer from this particular structure? My question is, there are 12 vertices. Okay, that means there are 12 accounts in this particular social network. Now my question, I just posed you some other questions. Whoever knows, you can give your answer in chat box. What are all the ideas, or what are all the inference that you can get from this particular structure about this 12 persons, about this 12 persons of this particular social network? Just by looking into this particular graph structure, you can give the solution. You don't want to have any other thing. Just by looking into this graphical structure, you can give the solution. Anything about the persons who have involved in this particular social network. Any answer from your side? Okay. Each person is in contact with at least one, except E. L is connected only with E. L is connected with E. F. L is connected only with F. Very good, Akash. Okay, then each person is connected with at least one except E. So what can we tell about this particular vertex E? F. Yeah, I can understand. Akash, you can understand. What can you say about this particular vertex E? So the vertex E is an isolated vertex because he is not having any connections with others. If a person is there in the social network like this, automatically the system will identify some other persons and he will be notified to add some accounts using the phone numbers of their contacts and in other ways and all, right? So of course automatically he will be connected with others. Fine. If he is alone in the social network, if there is any information, if it is passes to E, can it be shared to anybody else? Certainly not, right? So finding an isolated vertex is a problem. We need to find out the isolated vertex. And not only that, you can see whenever you enter into the Facebook account, you can see every day, one taking showing one particular friend's photo, and you will be notified to add him as a friend, indicating that 3 mutual friends or 100 mutual friends, like that. So once if you see number of mutual friends is higher, we will be very curious about it, who is that, and we will be looking into who is actually, right? Fine. So the number of persons, the number of mutual friend, how it is being calculated, you can easily interrupt that particular thing from this particular graph. You can see now both A and C, the persons A and C. Can you say anything about the persons A and C? Persons A and C. Are they friends? Are they friends? Are they friends? How? A and C actually not connected. They don't have age between them. Only if they have edges between A and C, they are friends. Because our graph is structure. Yeah, they have mutual friends. They have mutual friends, but they are not friends. Fine. So A and C have mutual friends. Let me calculate how many mutual friends are there for A and C. A and C are actually not connected, but they were connected in terms of a path. The path is A, D, C, right? So through this particular path, what is the length of this particular path? It is a path of length 2, right? So if there is a path of length 2 between the vertex A and C, and if there is no connection between A and C directly, then we can say there is one mutual friend. So now you can understand that the number of mutual friends of A and C is nothing but number of distinct path of length 2 between A and C, provided A and C are not connected. Okay, even if the A and C are not connected, if you want to calculate mutual number of mutual friends, this is nothing but number of path of length 2 between A and C. Now an algorithm works. Right, many number of algorithms are there for finding path of length any n, for path of length n. So it may be shortest path or longest path. Once if you fix the length of the path is 2, the algorithm itself will calculate the number of paths between the particular vertices, right? So the algorithms runs in terms of software. The computer programs itself, it is being constructed using the algorithms of graph theoretical ideas. See how it is applied there, and we find out we just find the answer when you open that account and you are being given this number of 30 number of mutual friends you have with somebody else. You can add them. The same number will be going to particular other person. Right? So see how it is. So path of length 2, path of length n. What are all the parameters? What are all the things? These are all the parameters and the concepts of graph theory. And graph theory has a variety of tools and results and algorithms to to apply in this particular situation. Right? So what are all the things that we have in the graph theory can be used here? Algorithm has to be developed. Sometimes one algorithms may be lengthy. We need to go for some other algorithm, right? So that is what the research. Okay. So if it is a very lengthy and if the program is very lengthy and if it is not give optimizing result, we have to think over and we have to think about it. That is what the research. Okay. Fine. So, okay, what others can be given the answer? Okay, fine. Let me tell you a few parameters of the concept. One thing, social network is actually depends on the number of vertices belonging to the social network. That is what the density, I mean, size of the network. The size should be very large. Then only you will be a part of that particular social network. If nobody is having that account, means even if you log in, there is no use, right? So people are now, the youngsters are going to Instagram because of the huge structure, huge size of the Instagram, and day to day it covers, attracts many accounts, right? So the size is very important, not only the size. Let me come to the point. According to a social network, density is also very important. Density means the people should be connected. If there is no connections, if there are thousands or hundreds of people are there, but there is no connections, they are simply ideal. One or few connections only there. So there is no use of that particular. There is no use of that particular type of network. So people will run away from that particular thing. So the density should be improved. The density should be improved, right? So what is the density in terms of graph? Let me tell you a very simple point. The density of the social network is nothing but the number of edges. Size is nothing but number of vertices. Now let me pose to you a very simple question. How to find out the density of this particular social network from the degree of the vertices? See, we have the number of friends of each and every vertices here, that you can easily see. A has 2 friends, B has 3 friends, C has 3 friends, D has 3 friends, E has 0 friends, F has 2 friends, and so on. Can you calculate the number of edges without actually counting? This counting here, it is possible, you can easily count. But think about a huge graph, you cannot count it, right? So from the number of friends of each and every persons, if you want to find out the density of the particular network, we need the help of the graph theoretical ideas. We need the help of the graph theoretical theorems. We need the help of the graph theory persons and the developers, researchers, everybody, right? So very simple theorem of fundamental theorem of graph theory is applied. Okay, so you can simply here count and write the answer. But let me give how the solution is, the solution we got. A to L, the person, 12 persons having the number of friends. A has 2 friends, B has 3 friends, C has 3 friends, totally 24. Just divide it by 2. Just divide it by 2. It will be an even number. It is an even number. That is another result of graph theory. It is an even number. When you divide that even number with 2, that answer will be 12. That is what the density. You can check it now. There are 12 edges, right? So think about a very huge graph, 100 crores of accounts there, and it is very easy to calculate the number of runs of each and every persons. So the density can be calculated just by adding them and dividing by 2. How we got? We just got it from the fundamental theorem of algebra. It says that, handshaking lemma, it says that the sum of the degrees of all the vertices divided by 2 gives the number of edges. How beautifully we applied here to find the density of the network. So the density has to be developed based on this particular thing. So if the density has to be developed, means the system itself has to calculate the number of mutual friends between them and keep on notifying them to add the friends, or to identify the persons from the contact list and sending the messages, and for them also calculating the number of mutual friends. All are the procedures of algorithms that are actually developed in graph theory. Okay. And other problem of this particular network is finding click. Click means it is a complete subgraph. A few graph theoretical terms only I am using here, because even if students are not studying graph theory, you can easily understand. It is nothing but a subgraph in which the pair of vertices are adjacent. In which pair of vertices are adjacent? Can you find out click from this particular graph theoretical structure? If you find the click, you can type what are all the vertices which forms the click. A click is nothing but A subgraph, some number of vertices who are interconnected between each other. Who are interconnected between each other. You can find out. You can find out. You can think and you can say. Can you find a triangle from this particular graph? Can you find a triangle? If you find a triangle, that itself is a clique. Yes, that itself is a clique because all the vertices of IGH, very good Nandita, IGH forms a clique because IH are connected, HG are connected, IG are connected. So each and every pair of vertices of that particular component is connected. So this is what a clique. Okay, so clique, what is the role of this clique in the social network? You imagine a social network has a crore and crore of accounts. But think about your class. How many students are there in your class? How many students are there in your class? Anyone can answer? 52. These 52 students are 57. These 52 or 57 students actually form a clique in the social network. You know why? Because all 52 students are actually connected between each other, mutually connected, because the people, everybody are knowns, right? So you will be connected, interconnections will be there. So in the entire social network there will be a clique having the size 52 or 57, right? If I find a person from outside of your class, if I find a person from outside of our class, but he is very nearer to your class. The nearer means, I mean in social network only. Imagine that I, H, G are the members of your class, right? And there is an information has to be shared. To which vertex? Suppose if it is, if the information is there in D, how long it takes, how many shares it takes to reach this particular group? If the information is there in D, how many shares we need to share that particular information to this particular group IGH? Yes. First, D, when D share the information, it goes to C. When she share the information, it reaches the particular group. Once, if H share that particular information, that will reach to the entire class. Right? So, the people around us, they are always interested to identify a group of people having a like mind. Right? Okay, third year students. Definitely you would have crossed 18 years of age. Okay, so if you are a third year students of a class, of a college, certainly you will be having a vote, you will be in the voters list, right? So the election campaign through this particular network, if it comes and if it reaches you, that will be beneficial. But if it goes to the first year students, it may not be useful to that extent, right? Okay, so the nearing clique, finding the nearing clique is another problem. Finding a nearing clique. So if D is a person, and from the D to reach this particular clique, how many shares we need? And what is the shortest way of sharing? Okay, suppose if D share the information, it goes to C, but it won't goes to J. Through C, it will go to J. Even if it goes to J, it will never reach to this particular group, right? So we need to find out the shortest route between the persons to the clique. So this is what a problem of finding the nearest clique. Okay, so this finding a nearest clique is to find the group of people, to know about the people and to reach the informations to the particular people. Finding clique is another problem of a graph theory, and algorithms works out for finding the clique. Fine. Okay. So we know in the previous election of American election, the social network played an important role, right? So studying the minds of the people, mindset of the people, and passing the informations in such a way that to convert their mindset into this particular thing. So what you are sharing and what is your mindset, based on that they share the informations, right? Okay, so these things can be easily calculated by finding the nearest click. If you go to the research ideas, you can find out a lot of papers in finding the algorithms which are used to find the nearest click. Right? Okay. So these are all a very few examples. These are a very few examples, and from the known things we applied. Known things we use our graph theoretical items to this particular things. You can think about the social roles. Social roles means maybe as you are a student, you may have several friends in your age group. You may have several friends in your age group. That is your social role. It determines your social role. Okay, fine. So these edges, if it is giving, if we give some patterns for the edges, that is another problem. Giving patterns for edges of a person. Same type of one type of patterns will be given to one type of relationship. Suppose if you have relationship between your family members, right? So they may not belong to your age group, but your social role should be in that particular area also. Okay, so studying the patterns of relations among the nodes and finding the regularities, how you are regular to socially. Only if you have friends in your age group from your college or outside of your college, other students, but not having any social role in other areas like family or any or something else, then your social role is not good, right? So it should be irregular. There should be irregularities. So that can be studied from the patterns of relations among the nodes. I'm not going into how it is being studied and what are all the algorithms and all. But as a mathematics students, we have to know how it is applied. You know, because these things, all these things are applied. Geodesic distance, number of relations in the shortest possible path from one node to other. So number of relations, how many shares you need to pass an information from one person to another person. So this is what if the shortest possible path become a path of length 2, that will become a mutual friend idea, right? So more than 2 will also be helpful. Closeness centrality, distance of one node means we just change it as a person or actor. We are all actor of a part. We are all actor of the social network. Distance of one node to all others in the network. That is closeness centrality. Betweenness centrality, number that represents how frequently a node is between other nodes in geodesic path. How frequently it is. That is, you will be a mutual friend for two friends. Right? You will be a mutual friend for two friends. Like that, to how many pair of friends you are the mutual friends. That is what betweenness centrality. Okay, so all these parameters are calculated based on the ideas of graph theoretical terms. And once if there is an idea means there is an algorithm. If there is an algorithm that can be easily given in the form of instruction to the computer. That is called a program. The program calculates everything, right? Okay, so this social network graph, if you look into simply, it is a network only, but now you can see how this particular thing is converted into graph theoretical ideas and how we are applying it. Recent days, the research is going on. How to analyze it is what is an importance, analyzing page importance, giving page rank for web application. This is what the web application of social network. The page importance can be calculated. You can find the rank for each and every page. And based on the rank of the page, the Google will choose the page. Discovering community. This is what I told, finding near clicks. and analyzing trust, propagating trust, using propagated trust to fight spam, right? So this is another application of the social network graph in web application. Lot many things, we cannot go into depth of each and everything, but as a students you can get into this, what is that and how to find out. Just you search finding nearest click discovering communities in social network graph. You can have a plenty number of ideas and you can think over, and that will create your research idea. It is a very beautiful mathematical model. It is very interesting and it can be easily explained and others can easily understand. Even if they are from other discipline, if they are from biology or they are from chemistry or anybody else. If we put a diagram and explain, even students, you know well about a graph, and teacher comes and explaining graph by constructing a diagram, you will be really interested. Instead of explaining everything in an abstract manner, once if they draw the diagram, you will be understand. You will be interested towards the class and you will be listening that also, right? So hopefully you are enjoying the graph terms. At the same time, you have to look into the recent research ideas of the graph theory. May be useful for your higher education and your future research and all. How it is applied in our day-to-day life, we don't know. Are we knowing about all these things? Certainly we don't know, but it is being applied. Social network analysis is the study of relationship between individuals, including the analysis of social structures, position, role analysis, and many others, right? Finding the neighbors, friends are represented by the graph. What are the tasks of this? There are several tasks. Now this is an important part of the lecture. Why we need to study this task of the social networking analysis? From the task only, we will be able to understand what part of research is going on day to day, right? Centrality analysis, I told, it aims to identify the most important actors in the social network. Most important actors, they may have many likes or they may have many friends, and it is that most important actors is a center of attraction for a community. Centrality is a measure to calibrate the importance of an actor. This helps to understand the social influence and the power in a network. As I told earlier, community detection is another task. Actors in a social network form a groups. This task identify these communities through the study of network structures and topology. Our position, our role analysis, identify the roles. Okay, this different ideas and different techniques. Everything is based on the graph theoretical ideas. I'm not going to get into this one in deeply. But students, I want to motivate you towards this particular mathematical model. I started from what is mathematical model, and I slowly come to a model of graph, and I gave an example how it is being applied in the social network, and we can understand how it is beautifully applied in our day-to-day life. You can now think about how it can be applied for your problems. You may have something in your mind that, okay, how to get share our ideas immediately to the other peoples in the same mindset and other things and all. Once if you have any problems in your mind, that may be converted as a problem of graph, and we can give the solution for them. Or you can interact with the computer science or networking people to talk about these things, and you will be a best one to give the solution for them, right? So I don't have much time for explaining, going for any other ideologies. I have some other slides on chemistry also, but hopefully I can meet you in any other meeting to tell about to talk about the other ideas and all. It's a very excellent model, can be applied for the chemistry, for sociology, for biology, for everywhere, in all science, engineering sites. If we take a simple block designing, civil engineering, it is a separate area, so that we can talk 2 hours on them. Or chip designing, we can talk 1 hour on them. So like that, right? So really, it will be a it is a useful model for many of the situations. So you can also think about this one, and you can open your mind and think about what is the future research, and you can have a lot of ideas and other things. Thank you, students, for your patience. And if there is any questions, you may raise in chat box, or you can ask me.
Students, any question, please ask the staff. Sir.
It is very tough to listen in the evening time, right?
No, sir, no, sir. Very interesting topic, sir. So all of them enjoying and
Yes, usually students likes this graph.
yes.
Yeah, they used to say that the graph theory is very good, but it is. In my part of view, research is not easy to that particular part. But the understanding and finding, explaining the terms to others is very simple, and really they enjoy their class. They enjoy their graph theory terms in the classrooms.
Yes, sir.
So that's why the model is this particular model has plenty number of applications, and you can all think over about this particular model in the day-to-day real-time problems. That is my aim of this talk, and thank you very much for all of you.
Thank you, sir. Thank you so much. Saranya?
Ma'am, shall I deliver the vote of thanks, ma'am?
Okay, pa.
Good evening, everyone. I'm Akash from second year BSc Mathematics. Sir, your session was very nice and interactive for all. Though it is in evening, but we all enjoyed a lot and gained more knowledge about the mathematical models and how we are doing more important what we are doing. So through your sessions, we have learned that there are many ways to do one thing, but as a mathematician and as a student of mathematics, we have certain models we can do. So thank you for your session, sir. And in this juncture, I take immense pleasure to thank our uh, ma'am, Dr. T. Brinda ma'am, and our convener, Dr. T. Kunasegaran, our HOD, sir, and the coordinators, Dr. K. Shinbagam ma'am, and Dr. L. Saranya, especially the students without whom this is not possible. And this is a session we enjoyed a lot, sir, and hope our students, all the people in the session enjoyed the nuances of applications of mathematical models in real life. So I extend my hearty thanks and gratitude to Dr. Akbar Ali sir for this immense effort. And also, I extend my thanks to Mr. T. Tamil sir for his technical support, which is also streaming on YouTube. So thank you so much, sir. Thank you.
Thank you, Akash. Thank you for your elaborate vote of thanks to all of you. Thank you very much. This juncture, I would like to thank Dr. Gunasegaran sir for giving me an opportunity to meet you all in this virtual platform. I really enjoyed the session, and I would like to meet you in person in some other topic. Certainly, you will have that opportunity. I think so. I'm really thankful to DG sir, and also to Dr. Senbagam ma'am was arranged such a nice webinar, and also all the students who are very interactive in the chat box. Really, whenever I ask questions, you are listening and you are answering. It was really interested. I hope all have enjoyed. I can see your comments from the chat box. I'm really happy, and because I was like a student. I was like you in PhD CAS almost 22 years back. In those days, I know how to improve ourselves just because of the environment of PhD CAS. Hope you also enjoying that. You are studying well. Really, I would like to meet you all in any other situations in PG campus itself. Thank you all. Thank you very much. Thank you, Gunasegaran sir, for giving me this opportunity. Thank you all.
Thank you, sir. Thank you so much. Okay, sir. Thank you so much.
Thank you. Shall I leave now?
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.